Welcome back to our series about some of the key problems from the BC Summer Packet. Let's take a look at number 7. They gave us this piecewise function with unknown constants a and b as coefficients. It's the joint between the pieces at x equals 2, and we're supposed to find the values of the constants a and b such that f is differentiable at x equals 2. I'm going to start out by giving, I guess, what you might call a little hint or a refresher. So you might want to listen to this part of the video and then pause the video and see if you can finish solving the problem for yourself. So here is the hint / reminder that I will give you. So the first thing to remember is that differentiability implies continuity. So one of the things we're going to have to do here is ensure that f is continuous first, and that will give us one piece of information that we can use. The second thing that I would remind you is that you're going to need to use one-sided limits. This is going to be helpful for both determining continuity at x equals 2 and differentiability. So this would be the point where you should pause the video and see if you can solve the problem yourself given these hints. Okay, well, let's dive in and see what we can do. I said we're going to deal with continuity first. So we need to show that the limit as x approaches 2 from the left of f of x is equal to the limit as x approaches 2 from the right of f of x, and that both of those are equal to f of 2. So let's take a look here. The limit as x approaches 2 from the left is going to be the limit of bx squared plus 6x. The limit as x approaches 2 from the right is going to be of ax cubed, just based on the fact of the way the inequalities in the piecewise function come out. F of 2 is actually going to just be b times 2 squared plus 6 times 2. I've substituted 2 into the first piece of the function, again noticing that the equality bar here for x equals 2 is associated with the first part of the function. Now, evaluating these limits, the left-hand limit is also equal to b times 2 squared plus 6 times 2, so we really don't need this third equal sign here to make it all work. But we know we're going to have 4b plus 12 equals, well, now we plug the 2 into ax cubed, that would be 8a. And now we have an equation that relates the unknown variables, or the unknown constants, a and b. Now, again, this might be a good place to pause the video. See if you can use the same method on f prime of x to find a second equation that relates a to b. Okay, so let's pick back up with differentiability. That would be that the limit as x approaches 2 from the left of f prime of x has to equal the limit as x approaches 2 from the right of f prime of x. We don't have the third term over here of equals f prime of 2 because we aren't sure that f prime of 2 exists, and the only way it will exist is if these two limits are equal to one another. So we don't need that third bit here. Okay, well, this will be the limit as x approaches 2 from the left. Well, I need the derivative of f for x values less than 2. So I'm going to take the derivative of the first piece of the piecewise function. That's going to be 2 times b times x plus 6. And now that has to equal the limit as x approaches 2 from the right of f prime of x for x values greater than 2. Well, that's going to be 3a times x squared. Now let's evaluate the limits by substitution. 2 times b times 2 is going to be 4b, and then add the 6. So the left-hand limit is 4b plus 6. On the right-hand side, we're substituting 2. 2 squared is going to be 4. 4 times 3 is 12, so we have 12a. So we have a second equation that relates the unknown constants a and b. All right, now again, pause the video and think about how you would algebraically solve for the constants a and b now that we have two independent equations that describe the relationships between the variables. Okay, so let's proceed with solving the system of equations. We've got 4b plus 12 equals 8a, and we have 4b plus 6 equals 12a. Now, we could solve this system of equations by using substitution, isolating a variable, substituting into the other equation. But you might notice that both of the equations have the 4b in common, so we can use the method of elimination. We can eliminate the b variable by subtracting the second equation from the first equation. So 4b minus 4b is 0, so there's going to be nothing left in this column. 12 minus 6 is 6. 8a minus 12a is negative 4a. Dividing on both sides by negative 4, we get that a is equal to negative 3 divided by 2, or negative 1.5. Now, we just need to find b, and here we do have to use substitution. So I'll take the first equation, 4b plus 12 equals 8 times a, but now we know that a is negative 3 divided by 2. The 2 goes into the 8 4 times, so the right-hand side is equal to 4 times negative 3, or negative 12. So 4b plus 12 equals negative 12. So 4b is equal to negative 24 when we subtract 12 from both sides. Now we divide on both sides by 4, and we get negative 8. So now we have our answers. A has to be negative 3/2, and B has to be negative 8.